Even a stem and leaf plot would kind of show you your shape, especially if you kind of turned it. A dot plot, something like that. When we are talking about uniform, what that means is the frequency is evenly spread, or everything has the same y value. So it would be like a histogram. Oh, that's really crooked, but pretend. Where it's just straight across. Everything has the exact same height. That's uniform. Okay, if I were looking at the probability, if I'm going to roll a die, probability of each side. Probability of rolling a 1 is 1/6. Probability of rolling a 2 is 1/6. Probability of rolling a 3 is 1/6. They all have the exact same probability. That's uniform. Bell-shaped is the one that we are going to really focus on, especially in the second half of the semester. And that's where it's like peaks in the middle, so you have more in the middle, less on the sides. And it's kind of symmetric, about the same to the left and to the right. You can see this from like a histogram as well, so the ends would be pretty short. As you get to the center, you have your peak. Rarely will our data be perfect, so most of the time we are kind of giving our best guess of how we would describe the data. And sometimes there is a little, it's not quite clear, and so there might be a couple possible ways you could describe it. Skewed right says the tail of the right peak is longer than the tail of the left. Okay, so what skewed right means is as it goes on, your data trails off to one side. Okay, or if you're looking at a histogram, you might have something like this. We're hitting our peak, but then it just keeps extending off to the right. So we have more points on that right-hand side. Skewed left means you have more points to the left. So that tail is longer. Maybe it peaks right here, and it looks something like that. Okay, so I have more on the left-hand side. Do you guys understand what our data looks like in each of those? So I think there is an example that I did actually print on your slides. How would you describe this? This is the data we had from the eruption of Old Faithful. Where's the peak at? Okay. So that's like our peak. So if we think about this, if we drew kind of a curve here, how would you describe that? Skewed left. And again, it's not going to be always clearly one or the other, so you're just using your best judgment. Is that okay? All right. Let's look at section 2.3. This one, we are not really working through a ton of examples. I'm just showing you some other ways that data might be represented, and we could see those. And also we have a couple terms, so you might have to jot your terms somewhere in here. A midpoint. So we saw with our frequency distributions that sometimes we used classes. So when we did like the Old Faithful example, we had classes for our data. We said times between 670 and 679, and the next class was 680 to 689. So the class width is how far it is from the beginning of one class to the beginning of the next. If I want the class midpoint, it's the middle. So you add 2 lower class limits and divide by 2. So for instance, when our classes were like this, if I wanted my midpoint, I would say, well, 670 plus 680 divided by 2 gives us what? And once you have the first midpoint, it's actually pretty easy to get the rest. What was the class width on this? The distance from one class to the next? 10. So once you have the first midpoint, you just keep adding 10 to get every other midpoint. So you don't have to calculate all of them. You just find one and do your class width to get the others. So we can use those to draw what's called a frequency polygon. And I think, did I print this slide for you? Yes. Okay. So this is called frequency polygon. So it's kind of like a line graph, but it has a couple additions to it. The x-axis is for the class midpoints. Okay, because if I'm trying to put a single point to represent everything between 670 and 679, I really need a single x value. So our dots are at all the class midpoints. The other thing about a frequency polygon is it always connects to the x-axis. So you have to add an extra point at the beginning and end with a y value of 0. These are probably easiest to do on Google Sheets. So let's try one. I'm going to give us just a small example, and we'll kind of look at how to create one. So go ahead and get Google Sheets going. So we are going to use this as our data. If we wanted to make a frequency polygon, we would need to insert a column for the midpoint. And that'll be the point that we plot on the x-axis. So what's the first midpoint? How do we find it? So 8 plus 9 divided by 2 is 8.5. What's my class width on this? It's actually the distance from the start of one to the start of the next. So it's just 1. So if you just keep adding 1, you'll get all of your other midpoints. 9.5, 10.5, so on. Okay. If I tried to do this right now, so I can insert a chart. Okay, it gives me options. We want one that looks like a line. So this one, this is not a true frequency polygon because what is it missing? The zeros. So in order to make it work, I'm going to delete that one off. We have to add in something. We need something at the beginning and end with a frequency of 0. And the midpoint, our x value, we just have to continue the pattern. So what would have been the midpoint before 8.5? 7.5. And my last midpoint would be 15.5. So you do have to add in those 2 made up points. And then you could go to insert your chart. And we want the line. And you can do some formatting things, you know, change titles and whatnot, add points. But that's the graph that I'm looking for. So you have to find your midpoints, and you have to add in those zeros before the first point and after the last point. that okay? Sometimes I could ask you to make a cumulative frequency polygon. So if I were doing that, cumulative frequency is everything up to that point. So we start out with 0. The next time I add 2, so I'm at 2. But if I add 2 more, what is my cumulative? That's just saying how many up to this point, so it would be 4. Okay, the next time, if I add 4 more to the 4 I already have, we are at 8. Okay, then we add 1 more, so we have 9. Add 1 more, that's 15. Next ones we had 13, 28, 35. So cumulative frequency is the number up to that point. Okay, so maybe you are creating a group and we are slowly adding more to it. We want to know how many do we have in our group so far, not just how many did we add this round. And you could graph it the same way. If I ask for the graph of that, you just highlight your midpoint and your cumulative. Remember, if you do control, you can highlight both of those, and you could insert your chart from there. So it looks something like that. Any questions?